Hello friends. Friends, today we will discuss and derive variation of mass with velocity relation in relativity. Now, suppose there are two inertial frame of references, S1 and S2. Two inertial frame of references, S1 and S2. I have already discussed in my previous video lectures of relativity about these frame of references. Okay, S and S dash. Okay, this frame is S and second one is S dash because I have used this nomenclature in every video lecture. Okay, and S dash frame is moving. S dash frame is moving with a uniform velocity v along x-axis. Along x-axis. Okay, x, y, z axis. O is the observer. O dash is the observer for S dash frame. Okay, now suppose there are two particles moving in opposite direction in this frame. Okay, in this frame. Okay, this frame may be a train moving. Okay, a train moving because we are discussing about the relativity, and this train speed is comparable to the speed of the light. Okay, and this is suppose a stationary train. Okay, a stationary friend, a stationary car. Now suppose there are two particles moving in opposite direction, frame S dash, particle A and particle B. Velocity of particle A will be u dash. Velocity of particle A will be u dash and particle B will be minus u dash according to the observer O dash. According to the observer O dash, the velocity of the particle A is moving along this direction, so its velocity is u dash. Particle B is moving along this direction, its velocity is minus u dash. Okay, so this is the basic diagram to derive this result. Okay, so let us study the velocities and mass of these particles from frame S, that is from the stationary frame. Now velocity of particle A will be u1 and the velocity of particle B will be u2 from frame S. And these are given by addition of velocity relation respectively. Please see the playlist for all the lectures for the relativity. So u1 equals to u dash plus v divided by 1 plus u dash v by c square. This is from addition of velocity relation. Okay, u2 equals to minus u dash plus v 1 minus u dash v by c square, because this is for the particle B, and the particle B velocity from frame S dash is minus u dash. This is equation number 1. This is equation number 2. Now, as the particles are moving to each other, at certain instant they will collide. Okay, particle A is moving along this direction, particle B along this direction. At a certain moment they will collide and momentarily came to rest. Momentarily they will come to rest. But even when they came to rest, they travel with velocity of frame S dash, because these particles are colliding in this moving frame. Okay, if they will come to rest, even then their velocity will not become zero, because then they will travel with the velocity of the frame, with the velocity of the train. Okay, fine. And suppose m1 and m2 are the masses of A and B from frame S respectively. So according to the law of conservation of momentum before collision is equals to the momentum after collision. Therefore m1 u1 plus m2 u2 equals to m1 plus m2 into v, because when the particles will collide, their masses, joint mass will become m1 plus m2. Their individual velocities will become zero, but they will travel with a velocity v. So this will become m1v plus m2v, okay, or m1 u1 minus v equals to m2 u2 minus v. Okay, now put equations 1 and 2 in above equation, 1 and 2 in above equation. Okay, so value of u1 and u2 we have to put here. So it will become m1 u dash plus v divided by 1 plus u dash v by c square minus v equals to m2 v minus of u dash plus v divided by 1 minus u dash v by c square. Okay, now then take LCM of terms in the bracket and solve. Okay, take LCM and then solve. We will get, take LCM, okay, and solve it. So we will get m1 1 divided by 1 plus u dash v by c square equals to m2 1 divided by 1 minus u dash v by c square, or m1 by m2 is equals to 1 plus u dash v by c square 1 minus u dash v by c square. Equation number 3. Okay, now take square of equation number 1. Take square of equation 1, then divide both sides by c square and subtract both sides by 1 or from 1. Okay, we will get 1 minus u1 square by c square equals to 1 minus u dash plus v divided by c 1 plus u dash v 1 plus u dash v by c square whole square. Okay, now again taking LCM on the right hand side and solving, we will get 1 minus u1 square by c square 1 plus u dash square v square by c4 minus u dash square by c square minus v square by c square divided by 1 plus u dash v by c square whole square. Equation number 4. Okay, so similarly, by squaring equation 2 and then dividing both sides by c square and subtracting both sides by 1. Okay, similarly, squaring equation 2, dividing both sides by c square and subtracting both sides by 1, we will get 1 minus u2 square by c square 1 plus u dash square v square by c4 minus u dash square by c square minus v square by c square divided by 1 minus u dash v by c square whole square. Equation number 5. Now divide equation 5 by 4. We will get 1 minus u2 square by c square, 1 minus u1 square by c square equals to 1 plus u dash v by c square whole square, 1 minus u dash v by c square whole square. Okay, now take square root on both sides. Take square root on both sides. We will get 1 minus u2 square by c square root 1 minus u1 square by c square root equals to 1 plus u dash v by c square, 1 minus u dash v by c square. Equation number 6. Now compare equation 6 and 3. Equation number 3. Okay, this is our equation number 3. 1 plus u dash v by c square, 1 minus u dash v by c square equals to m1 by m2. So compare equations 3 and 6. It will become m1 by m2 is equals to 1 minus u2 square by c square root 1 minus u1 square by c square. Equation number 7. Now this is basically a bit of complicated result. Okay, to make this result simple, let us assume that the particle B is in the state of rest from the start, from frame S. State of rest, particle B is in the state of rest from frame S. That is, it has zero velocity before collision. Therefore u2 is equals to 0 and m2 is equals to m naught. Okay, m2, suppose, because u2 will be 0, and then suppose m2 is equals to m0, where m0 is the rest mass of particle. Okay, rest mass of particle. Therefore equation 7 will become m1 divided by m naught equals to 1 root of 1 minus u1 square by c square. Now suppose assume m1 equals to m and u1 equals to v, because now there is no comparison with 2. So it will become m divided by m naught 1 root of 1 minus v square by c square, or m equals to m naught root of 1 minus v square by c square. This is the variation of mass with velocity relation of mass with velocity relation in relativity. Now what it interprets, now suppose, because m naught is a rest mass, because suppose you have a mass of 60 kg. Now if you will solve this result, root of 1 minus v square by c square, okay, if you will solve this result, this result will always be in decimal. This result will always be in decimal. Now suppose m is 10 kg, and suppose this result is 0.1, so m will become 100. Suppose rest mass is 10 kg, and because v is always lesser than c, and after solving this result will be in decimal, root of 1 minus v square by c square. So 10 divided by 0.1 is m is equals to 100. So variation of mass with velocity means that mass will appear more. Okay, this is the meaning of variation of mass with velocity relation. Okay, and in special case, if v is very less than c, then m is equals to m naught root of 1 minus, this will become negligible, 0. So this will be same, m is equals to m dot. So this is all about the variation of mass with velocity relation. If there is any doubt, please share in the comment section. Thank you. Thanks a lot.